Hello everyone. In this video we're going to be solving a cubic equation. I'll be introducing two methods. Even though I'm not going to go into the details of the first method, it's something that we've done over and over. Hopefully you got the idea. So for this problem, first of all, we could use the cubic formula, right? Let me go ahead and divide both sides by 4 first. So we get x cubed minus 5 over 2x squared plus 7 over 2x minus 5 over 4 equals 0. To be able to use the cubic formula, I'm going to get rid of x squared. So let's go ahead and set x equals y plus 5 over 6. Now where do I get that from? You take the coefficient of x squared and you negate it and divide it by 3. The reason why you divide by 3 is because this is cubic, so you have to divide it by degree. Make sense? The opposite of negative 5 halves divided by 3 plus another variable is going to give you what to substitute. And when you set x equal to that, the quadratic term disappears. Good luck with that. And you get the following: y cubed plus 17 over 12y plus 55 over 108 equals 0. This is not a very pleasant equation, but don't worry about it. We're going to solve it by using the cubic formula. Even though I'm not going to show you all the details, hopefully you can follow up. So here's what I'd like to do. First of all, I want to call this a plus b. And I want to write my equation as follows. I want to isolate the constant term because I'm going to make this look like an identity, which is a plus b cubed minus 3ab times a plus b equals a cubed plus b cubed. So the idea relies upon turning this cubic into a quadratic by using this identity. And now we're going to compare these two equations. Remember, a plus b is y, so this is y and this is y. And the coefficient of y here is 17 over 12, which should equal this number. And the constant on the right hand side is this number, which should equal this number or this quantity. All right? So from here we get the following: negative 3ab equals 17 over 12, which means ab is equal to negative 17 over 36. And this means a cubed plus b cubed is equal to negative 55 over 108. This gives us a system. This turns into a quadratic if you cube both sides here and replace b cubed with something in terms of a cubed, so on and so forth. Again, I'm going to spare you the trouble here and give you the y values that work. From here, you're going to get y equals negative 1/3 and two complex solutions, which is 1 plus minus 3 times the square root of 6i divided by 6. So those are going to be the y values. And if you back substitute, remember, x is y plus 5 over 6. And if you replace x, y with negative 1/3, which is negative 2/6, you're going to get 3 over 6, which is 1/2. So from here, you're going to get basically x equals 1/2. And the others are also going to give you the complex solutions. You can definitely go for that. Let me go ahead and, so here's what I'm talking about. So by setting the, by replacing the y with this one, for example, let's just go with the positive one, right? Just add 5, 6 to it, and you're going to get 6 plus 3 root 6i over 6 for one of the solutions. For the other one, if you replace this with negative 1 plus 3 root 6i over 6, and then just add 5 over 6 to it, that's going to give you 4 plus 3 times square root of 6i divided by 6. So those are going to be your complex solutions. If you don't like the way of writing it this way, you can definitely call this x1, x2, and x3. All right? So those are going to be the solutions, and I have a cubic, so we should be expecting 3 solutions, right, from a cubic equation. Well, it was actually a quartic, but we kind of turned it into, well, it wasn't a quartic. What am I talking about? Okay, never mind. I got confused. So that is my first approach, and let's go ahead and take a look at the second approach, or the second method. So my second method is obviously smarter than this one because the first method is usually more painful, even though there are some exceptions. Sometimes I pick an easier method first. I don't really know, like depends on the mood, I guess. Like at that point, like I say, okay, this is going to be my first method. There's no really particular, reason for that. But anyways, this is my second method. So for my second method, I'm going to look at the coefficients carefully. They're pretty much all even numbers, except for the constant, but I don't really care about that. So I care about the coefficient of x cubed, which is 4. And I'm thinking, if I double this, I'm going to get 8x cubed, which is nice because 8 is a perfect cube. Perfect. Let's go ahead and do it. So multiply by 2, both sides. You get 8x cubed minus 20x squared plus 28x minus 10 equals 0. All the coefficients are even now. The constant, again, doesn't really matter much. So I'm going to work on the variables. Why did I multiply by 2 first of all? To get 8, which is a perfect cube. So 8x cubed is actually now a perfect cube, right? Isn't that perfect? Like you have a product that's perfect. So now I can write the 8x cubed as 2x to the third power. But I want to continue in the same manner. So instead of having x as my variable, I want to have 2x as my variable. And I can achieve that because 20 is divisible by 4 and 28 is divisible by 2. Obviously by 4 as well, but I don't care. So I'm going to write this as then 2x times 10, right? Well, actually I have to square, so 2x squared is going to be 4x squared. So 5 times 2x to the second power. Makes sense? 5 times 4x squared is 20x squared. Plus, I'm going to write this as 14 times 2x, and the constant is going to be constant because it's a constant. So now, what do I see? I see that 2x is the variable, new variable. So why not use substitution? Let's go ahead and set 2x equal to t, and then you're going to get t cubed minus 5t squared plus 14t minus 10 is equal to 0. And yay, we got a monic polynomial. Monic means the leading coefficient is 1. But not only that, this is a very special polynomial. Remember, I've been telling you all the time. Check the sum of the coefficients. What is 1 plus 14? 15. What is negative 5 plus negative 10? Negative 15. Their sum is 0. Awesome. So t equals 1 is a solution. Beautiful. Well, can I find the other solutions? Of course. You can go ahead and arrange this. T cubed minus t squared minus 4t squared plus 4t plus 10t. Notice that I'm taking terms to make this divisible by t minus 1. Because if t equals 1 is a solution, then t minus 1 is a factor, and I want to factor that out. So I have a balanced equation, which is really cool. And now I can factor by grouping. And notice that this is t squared times t minus 1. This is minus 4t times t minus 1. And this is plus 10 times t minus 1. And I can now take out t minus 1 and write the other factor as t squared minus 4t plus 10 equals 0. Uh-oh, we got complex non-real solutions from here. Of course, that should be expected. But t minus 1 equals 0 gives you t equals 1. We already knew that. But what is t? T is equal to 2x, which means x is equal to 1/2. If you solve the other equation, you're going to get the complex solutions. We already got that. Hopefully, you can handle this. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.